In the first problem here, we're looking to see which compounds are enantiomers, the same, or diastereomers. And if we're looking at F here, we can see that there is an OH on the second carbon that is dashed, and then there's another OH on the other side. So what I'm showing you here is a molecule where the OH is dashed. That is pointing back and away from you. And so that is back, and then we have the rest of the carbon chain here. If I turn the molecule over, I'm just flipping it over here, my alcohol is now pointing towards you. This is coming at you. And that is actually the structure you see in the second structure on F, where we have this bond here, and on the second carbon is the OH. So these are the same. And you can confirm that by determining the stereochemistry. So this is a 1, 2, 3. This would be R, but because the H is wedged, this is S. And then for this one, this is 1, 2, 3. The H is in the correct direction. This is S. They're both S, so they are both the same. In the second problem, letter G, we have an OH on the third carbon. And you can see this structure here where we have that chain. The OH is on the third carbon, and that is dashed, so it's coming out at you. So you can see that there. And if I flip it over again, the OH is now away from you, and you can see the second structure there in G. So these are also the same. And this does not have a center of chirality because these ethyl groups are the same. In the third example here, we will see two chlorines that are wedged. If we flip this over, we're going to get that right there. So these are also the same. Alright, for number 17, we're drawing the enantiomer for each of these compounds, which is just the one here. And you can do that the two ways where you draw the literal mirror image. So I have my OH here, and remember to keep your wedges and dashes the same if you're doing the literal mirror image. And if you draw it the other way, where you just flip everything, then we flip everything. So the chlorine was dashed, becomes wedged. Alcohol was wedged, it becomes dashed. And the methyl group is dashed, it becomes wedged. So that's another representation of the enantiomer. Here we're looking to identify the configuration of each chiral center. I have one chiral center here. My number 1 group is the alcohol. 2 is the carbon to another carbon. This is 2. This is 3. This is 4. My methyl group is 4, and it's in the plane, which means that I need to flip it. So I'm going to flip 4 with 1 because that's dashed, and I need it to be in the dashed position, so I'll redraw this. So what you can do is just draw the numbers. This is 1, 4, 2, and 3, and then go ahead with the flip, the double flip. And when I do that, I get 4, 1. This becomes 3, and 2 is now wedged. So when I draw my circle, 1, 2, 3, that is S. Alright, in F I have a couple other stereocenters to find here. This is 1. So my chlorine is 1. 2 would be this one right here. This is 3. 4 is wedged. 4 is wedged. So I'll have to take the opposite. So 1, 2, 3, this would be R. And we take the opposite to do S. So that one is S. For this right here, I have C to C, or C to C to Cl, C to C to C to C to O. This would be 1. This is 2. This is 3. And my methyl is 4, which is back, and so this one is R. And last one here, this is oxygen is 1, 2, 3. That is clockwise. My hydrogen though is in the wrong direction. So this would be R, but it gets flipped to S. Right, here we're looking at relationships between compounds again. And for this first dichloro compound, these are both wedged. The second one is wedged and dashed, so these are diastereomers. And in the second one, the OH is flipped, but the Cl's are also flipped. So this would be the enantiomers. Alright, we're answering questions about A through D. Determine the configuration of each chiral center. So for A we have 1, this is 2, 3. For A that is clockwise, so this will be R. And this is 1, 2, 3. This would be S, but the hydrogen is in the wrong direction. So this is R. So my alcohol over here is R. This is S, 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 and R, S. What is the relationship between A and B? A and B are enantiomers. Between A and C are diastereomers. And C and D, these are meso and or the same. So there's that mirror plane there. Here we're looking to see if these are chiral or achiral. There's no plane of symmetry here, but let's do the stereochemistry just in case. Let's look at the stereochemistry for this one. This is 1, 2, 3, so that one is R. 1, 2, 3. That would be R, but is S. So this one actually mirrors the other one, so this is achiral. This is the meso compound. In this structure here, we're looking at this alkane chain here, and we already determined the stereochemistry so that you can see that it was an achiral compound, but we can also manipulate the model kit here. And so what we have is the OH that is pointing forward, so that's coming out at you, and this other OH is pointing away. So that's what you can see right there. And if I rotate this around, so I'm just turning the carbon, I'm not disconnecting anything, I now have this. So we can see here that this axis mirrors the other, one half mirrors the other half. So this one is achiral, this is a meso compound. And this structure here, there's no way that we can draw it to have a mirror plane, so this one is chiral. Here's some more looking at relationships. In this one, the chlorine is dashed where the first one is wedged, and the bottom two are the same, so this is a diastereomer. And for I, both of these groups, if we drew them flat, are pointing up. And in this one, we have a down and an up. So these are diastereomers.